Why is the observer effect so strange in quantum mechanics? Have you ever wondered why the act of observing something can change what you are observing? This is the heart of the observer effect in quantum mechanics, and it is indeed a strange phenomenon. In the world of tiny particles, like electrons and photons, simply measuring or observing them alters their behavior. And like everyday objects that remains unchanged regardless of how you look at them, quantum particles exist in a state of multiple possibilities, known as a wave function. When you observe these particles, this wave function collapses, forcing the particle into a specific state. This means that measurement is not a passive act. It actively shapes reality at the smallest scales. One of the most famous examples of this is the double-slit experiment. When electrons or photons pass through two slits without being observed, they create an interference pattern on a screen behind the slits. This pattern shows that the particles behave like waves, passing through both slits at the same time and interfering with themselves. However, if you try to measure which slit a particle goes through, the interference pattern disappears. Suddenly, the particles act like tiny balls, going through one slit or the other. This change in behavior highlights how the presence of an observer or measuring device can alter the outcome in ways that defy our classical understanding of physics. What makes this even stranger is that the observer does not have to be a conscious being. Any measurement device, like a tiny electron detector, can disturb the particle's behavior. It is as if the particle knows it is being watched and changes accordingly. Scientists have even experimented with the degree of observation, finding that they can weaken or strengthen the interference pattern by adjusting the sensitivity of their detectors. From a weird science perspective, this suggests that at the quantum level, reality is not fixed. It depends on interactions with the environment or observers. This challenges the classical idea that particles have definite properties independent of measurement. The observer effect hints at a world where the line between observer and observed blurs, and where the act of looking changes what is being looked at in a very real way. This strange phenomenon has practical implications in fields like quantum computing and quantum cryptography. Understanding how measurement affects quantum states is essential in these areas. It also raises philosophical questions about the role of consciousness and reality itself. The observer effect stands out as one of the quirkiest and most fascinating phenomena in physics, reminding us that the universe operates in ways that can be both puzzling and captivating.